Okay, let's unpack this. Today, we are diving deep, really deep, into a view of reality that frankly asks us to maybe forget a lot of what we think we know about time. The source material we're looking at introduces something called infradimensional hyperfractal time. And the core idea time isn't just a straight line moving forward. No, it's presented as this incredibly complex multi-vector thing happening inside a hypersymmetric, self-similar structure. Sounds like a mouthful, I know. We're getting into the weeds of the hypersymmetric, hyperdimensional coherent resonance theory. That's HHHCR TOE for, well, maybe not short, but shorter. It's huge, it's dense.
Yeah.
So our mission today for you listening is to be your guides. We want to boil down the key ideas, map out these 5 different time axes, T1 to T5, and really try to understand what happens when they interact. Because the really big idea here, the one that shifts everything, is that the time you feel passing, linear time, T1, it's just an emergent property. It's like the surface ripple of much deeper hidden currents of time.
That's absolutely the starting point. And you're right, the HHHCR is challenging. It pushes us way beyond standard four-dimensional space-time. We're talking about the basic rules, the universe's operating system at a level we don't usually consider. This framework looks at scales that are truly infradimensional below the scales we normally measure. What we're digging into today is fundamental to understanding, well, coherence. What holds things together? What connects the fuzziness of quantum mechanics to the solid clock-picking reality we see around us? It's really about finding the mechanism that stops the whole universe from just dissolving into, maximum entropy, pure chaos instantly.
Okay, let's build this from the ground up then. The foundation. Infradimensional hyperfractal time. Now, infradimensional, that sounds like smaller than small, right? Smaller than quantum scales. How does that work for time, and what exactly is this hyperfractal structure?
Think of it like this. Our everyday reality, 4D space-time, that's like the user interface on your computer. It's what you see and interact with. The infradimensions, that's the underlying code, the firmware maybe running constantly beneath the surface, making the interface work. So infradimensional here means temporal structures existing at scales or maybe depths, below our standard perception, governing how reality coheres and resonates. In the hyperfractal, that's the actual shape these underlying rules take. It's described as this vast, incredibly complex, layered structure. You know how fractals have self-similarity? The same patterns repeat bigger and smaller. Well, this hyperfractal lattice is proposed as the universe's structural backbone, a multi-scale repeating network that influences dynamics from quantum particles all the way up to galactic clusters. It's not just geometry, it's supposedly the wiring diagram for time itself.
The wiring diagram, I like that. So if it's a lattice, a structure, what are the components? What actually manages time within this hyperfractal?
Good question. The key elements described are called scaling nodes. Picture them as junctions or hubs within this cosmic wiring. They aren't all the same, though. There's a hierarchy. Their position, how deep they are in the fractal layers, determines what they do. And crucially, these nodes are where the different time axes, T1 through T5, actually connect and interact. And it gets complicated because different nodes transmit different properties. A node deep down might broadcast strong coherence or resonance. One closer to our perceived level might influence time dilation or contraction locally. This immediately tells you time isn't uniform, even at this fundamental level. It varies based on this underlying structure.
Okay, so this infradimensional time operating through the hyperfractal is like the master controller. How does it actually impose order? How does it fight against the chaos, the entropy we normally see?
It apparently does it by setting the initial conditions for organization, for both tiny quantum systems and big macroscopic things. It provides the template, the parameters for how matter and energy should arrange themselves. By laying down this organizational blueprint, deep time guides complexity into existence, which leads straight to this idea of entropy balance. You're right, on our scale, T1 time, we see things break down, decay that's entropy increasing, reality moves towards disorder. But the HHHCR TOE suggests a counterbalance. Down in the infradimensions, coherence is actually increasing. These deep time layers are constantly building structure, weaving complexity, maintaining the hyperfractal itself. So you have this tension. Macroscopic decay versus infradimensional organization. And that tension is supposedly what allows complexity to keep emerging, preventing universal heat death.
Wow. Okay, so while we observe the universe running down in one sense, this theory says deeper layers of time are actively building it up, working against the flow. That completely reframes something as basic as the second law of thermodynamics, doesn't it?
It absolutely does. It suggests the second law might be an emergent property of T1, not the whole story.
All right, here's where it gets really interesting. 5 different kinds of time. T1 to T5. We need to get a handle on each one. How do these distinct axes work, and how do they all connect through this hyperfractal lattice you described?
Okay, yeah, the 5-axis, they're all linked through those scaling nodes we talked about. They depend on each other, but each one has a specific job governing a unique aspect of reality. Let's start with T1, primary time axis. This is the one we all know. Linear progression, cause and effect, the clock ticking forward in our familiar 4D spacetime. But the key thing, the absolute takeaway, is that T1 is emergent. It's not fundamental. Think of it as a macroscopic average, a projection, smoothed out from all the complex, nonlinear stuff happening with T2, T3, T4, and T5 underneath. T1 gives us that consistent story, the coherent narrative of events unfolding.
Hold on. If T1, linear time, is just a projection, does that mean causality itself, the idea that A causes B, is also just sort of an artifact of T1? Could things happen out of order or simultaneously in those deeper time dimensions?
That's exactly the implication the sources explore. T1 enforces strict cause and effect for us, for our observable world. But the behavior described for the deeper axes, especially T3 and T4, yeah, it suggests causality might be much fuzzier, maybe even irrelevant, at the most fundamental level. T1 is like the universe's way of simplifying things to maintain local consistency. Makes sense. Okay, what's next? T2. T2, cyclic time axis. This one's about anything periodic, cycles, think big, galactic rotations, planets orbiting stars, maybe even cosmic expansion and contraction cycles. And think small, quantum spin, particle oscillations, electron states. T2 is said to emerge from repeating closed-loop patterns within the hyperfractal structure itself. And because the fractal is self-similar, you get nested cycles, cycles within cycles. So cosmic rhythms are like massive echoes of quantum rhythms, all thanks to T2's architecture.
Whoa. So the reason my clock ticks, a planet orbits and an electron spins, might ultimately trace back to the same underlying cyclic structure in time that's connecting things across insane scales.
That's the idea. It implies a profound synchronization. Now, deeper still. T3, quantum time axis. This is where things get probabilistic and nonlinear. T3 governs stuff like quantum superposition, being in multiple states at once, and entanglement. It's linked to the deepest, most intricate layers of the hyperfractal. Down there, the nodes aren't fixed points, but represent probabilistic relationships, allowing these weird quantum effects like superposition to spread or exist. And its nonlinear nature shows up in its own uncertainty principle, at T2. Unlike T1's steady flow, T3 describes a temporal reality where duration itself is fundamentally fuzzy relative to energy. It's a time dimension that allows quantum systems to explore possibilities before, settling into one outcome we observe in T1.
Okay, so T3 is the time axis for quantum weirdness, the fuzziness, the uncertainty, the maybe this, maybe that before measurement.
You got it. Now, crucially for stability, we have T4, coherence time axis. T4 is all about duration of stability. How long does a system maintain its structure, its coherence, before it falls apart or decoheres? This applies everywhere. How long a quantum superposition state lasts before collapsing, how long a chemical bond holds, maybe even how long a galaxy cluster maintains its form. And T4's duration isn't random, it's deeply tied to the hyperfractal. The sources say coherence time depends on how well a system connects, or couples, to those deep stabilizing scaling nodes. Align poorly, decay quickly. Align well with these coherence boosting nodes, and you get much longer stability. It's literally about resonant alignment with the structure of time.
So things don't just stay stable because of local forces pushing and pulling. Stability itself is about how well something is plugged into the universe's temporal foundation.
That's the core idea. And finally, T5, resonance time axis. T5 is about harmonic synchronization. It governs how systems resonate together, how they sync up across different scales and dimensions. It's what allows, say, T2's large cycles to influence T4's small-scale stability. T5 represents the natural harmonics that arise because the hyperfractal is self-similar and layered. This structure inherently acts like a resonant conduit, a channel that naturally transmits and amplifies certain frequencies across all temporal scales. So a vibration down at the quantum level could, through T5, find an echo influencing something macroscopic. It's the glue binding the time axis together.
Okay, that leads us right into the engine room then. This relationship between T4, coherence or stability, and T5, resonance or synchronization. You said T5 connects things. How does that connection, specifically between T4 and T5, actually create the stability we see? How does it fight decay?
Right. The T4-T5 interaction is presented as the key stabilization mechanism. Think of T5's stable resonance as actively modulating T4's coherence. Imagine you have something very delicate you need to keep perfectly still. That's T4 coherence. But the environment keeps bumping it, trying to make it decay. T5 acts like a constant, incredibly precise nudge, like a tuning fork vibrating at just the right frequency, pushing the delicate thing back into alignment whenever it starts to drift. When T5's resonance frequency matches the system's natural coherence frequency perfectly, it can preserve that quantum state, that stability, for much longer. It actively pushes back against the decay driven by T1 entropy.
And there's actual math in the sources describing this, right? We don't need the equations themselves, but conceptually, what does that formula tell us? How does T5 change T4's decay?
Conceptually, the math shows T4 decay isn't just a simple exponential drop-off, like radioactive decay. Instead, the rate of decay itself is being periodically adjusted by T5 resonance. It's dynamic. So you have the natural tendency to decay, let's call it gamma, but then T5 introduces this rhythmic push or pull, that's the cosine term in the formula, modulated by a coupling strength beta. When that T5 push is timed just right in phase, it can temporarily slow down, halt, or even slightly reverse the decay process. It's like T5 gives the system periodic breaks from entropy.
Almost like hitting pause on decay rhythmically. That sounds very dynamic, like it's self-correcting, which points right to temporal feedback loops. Does T4, the stability state, also influence T5, the synchronization state, in return?
Absolutely. It's a two-way street, a tightly coupled system. The source material models this with coupled differential equations, basically showing how the change in one influences the change in the other. The analysis shows two key feedback paths. First, as we said, T5 resonance directly boosts T4's stability. It slows the decay. But second, the frequency of T5 itself is strongly influenced by how coherent T4 is specifically, by the square of T4 coherence. What that means is, if a system achieves a really strong state of coherence, high T4, it actually helps to lock in and stabilize the T5 resonant frequency it's coupled to. So high coherence stabilizes the synchronizing rhythm, which in turn helps maintain high coherence. It's a self-reinforcing loop that could generate long-term stability.
That sounds like a potentially stable, but maybe also delicate balance. If this cycle is the key, how do we know if a given T4-T5 setup will lead to stability, or just collapse into chaos anyway?
That comes down to stability analysis and eigenvalues. This is where it gets quite mathematical, but the core idea is crucial. The allowable coherence decay rates and the possible resonant frequencies aren't continuous. They're quantized. They can only take on specific, discrete values, like energy levels in an atom. And these values are determined by the geometry of the hyperfractal itself. Think of the hyperfractal structure as defining a set of allowed notes, or resonant frequencies, 12E20 by 820 by 99. These are the eigenvalues for the T5 operator. Now, the really important bit is that the math shows the eigenvalue for T4 decay. Basically, how fast something decays directly depends on which of these T5 resonant modes, which note the system is vibrating with. And the result: systems that manage to resonate in higher T5 modes aligning with more complex, maybe higher frequency nodes deep in the hyperfractal are predicted to experience longer T4 coherence times. They're more stable. The stability analysis then uses the characteristic equation from those coupled T4-T5 equations to predict the system's fate. Will it settle into a stable, steady state? Will it oscillate predictably? Or will the feedback run wild and lead to divergence, to chaos? The moment-to-moment nature of reality, according to this, depends on solving these complex temporal dynamics.
Okay, let's zoom out. If time works this way, multivector, fractal, active shellaging, what does it mean for the big picture? How does it change our understanding of fundamental forces like gravity or the evolution of the universe? So what does this all mean?
It fundamentally reframes the forces. They stop being just interactions in space and become, in large part, expressions of these underlying temporal dynamics. Take gravity. In this HHHCR-Toei framework, gravity is seen as related to hypergravity from higher dimensions, sure, but its effects in our dimension are actively modulated by T4 coherence and T5 resonance. So things like gravitational waves aren't just ripples in spacetime. They're re-envisioned as coherent resonances propagating through the combined T4-T5 structure of time and space. The local strength of gravity could actually depend on the local T4 coherence state of the temporal field.
Hang on. That implies if you could somehow locally disrupt T4 coherence, you might actually change the gravitational pull in that spot.
That's a potential implication explored in the sources, yes. Now think about electromagnetism. Its wave-like oscillatory nature is tied directly to resonance time, T5. The theory suggests that T5 modulation might be the very reason photons travel at a constant speed. Light propagation is locked into a specific, universe-wide resonant mode of the hyperfractal. T5 provides the underlying harmonic stability. And for the strong and weak nuclear forces, they're seen as emerging from symmetries breaking in compactified dimensions. But T4 coherence dictates how long particles interact, the stability of nuclei. A particle interaction becomes a temporal event defined by T4 duration. And T2, cyclic time, might explain observed periodicities in particle decays or interactions that current models don't fully capture.
It really shifts the focus. Physics becomes less about static properties of matter and more about the geometry and dynamics of time itself. You mentioned symmetry breaking. How does this active time play a role there?
Right, the sources argue that processes like symmetry breaking, think of the early universe cooling and the Higgs field emerging, giving particles mass aren't just spontaneous events, they are fundamentally temporal processes guided by these axes. T4, coherence time, is proposed to actually stabilize potential states before a symmetry break happens. It provides a stable window, a duration, during which the system exists in potential before settling into a specific lower energy broken symmetry state. So the unfolding of T1, our observable timeline, is defined by these sequential transitions. Time isn't just the stage, it's an active agent of creation, guiding how structure emerges.
That idea of time guiding creation sounds like it connects to the theory's cosmology, the big emergence theory, or BET. How does multi-vector time drive the universe's evolution in this model?
BET reframes cosmic history not as just smooth expansion after a Big Bang, but as a sequence of distinct emergence events. The theory talks about temporal loci. These are points where all 5 time axes, T1 to T5, converge or align optimally. When coherence T4, resonance T5, cycles T2, quantum potential T3, and linear flow T1 all line up just right, it creates what they call a nodal spark. These sparks are catalysts initiating new levels of complexity, maybe the formation of the first stars or galaxies, or potentially even the conditions for life. And once again, T4, coherence time, is the star player here. It acts as the negentropic principle, the force-creating order that balances out the overall trend towards entropy we see in T1. T4 ensures that complexity doesn't just happen by chance, but is actively driven and sustained, leading the universe towards richer structures.
It's a huge conceptual framework. To make it work, the authors must use some pretty advanced math. We skipped the equations, but can you give us the gist of the main mathematical tools they use to tie all this together, just conceptually?
Sure, 2 key mathematical structures are central to integrating the phi time axes and the fractal geometry. First is the temporal metric tensor. G0 by E10 ISU50 by 800 by E10 ISU50 by 830 by E20 OFIA 20 SPD. The regular metric tensor in relativity describes distances in spacetime. Well, this is a higher dimensional version. It defines the interval or distance, dtat, not just in space in T1, but across all 5 temporal dimensions. It mathematically encodes how T1, T2, T3, T4, and T5 are geometrically interwoven. The second tool is the temporal fractal moduli. M0 by E10 ISB50 by 800 by E10 ISB50 by 830 by 0 by E20 by 820 XPD. These are essentially scaling coefficients. They describe how changes ripple through the system, for instance, how much a change in T4 affects T1 transmitted via the fractal structure. These moduli are critical because they determine the local effects of time dilation and contraction based on where you are within the hyperfractal. They're the mathematical link between the deep hidden time dynamics and the rate of time we actually observe.
The theory is mind-bending, definitely. But let's bring it back to Earth, or maybe the lab. How could anyone possibly test this? What are the practical next steps for seeing if these hidden time dimensions are real?
Well, the most direct and perhaps nearest term relevance is in quantum information science. Think about quantum computing. The biggest hurdle right now is decoherence quantum states falling apart too quickly. This HHHCR TOE offers a theoretical blueprint to potentially beat decoherence. If you can engineer a quantum system to deliberately couple strongly with specific high-coherence T5 resonant modes in the hyperfractal, you might be able to actively stabilize T4, preserving entanglement and superposition much, much longer. That would be revolutionary for quantum computing error correction.
Okay, so it turns cosmology into a potential engineering guide for quantum tech. That's fascinating. What kind of new instruments would we even need to build to detect or interact with these infradimensions?
We need completely new kinds of sensors and manipulators for time itself. The sources propose 2 main types. First, infradimensional temporal sensors. These wouldn't measure T1 time like a clock. They'd be incredibly sensitive devices trying to pick up subtle fluctuations deep down. Specifically, they'd be hunting for the characteristic harmonic frequencies of T5 resonance and trying to directly measure the T4 coherence decay rates in various systems. The goal would be to map out those T4, T5 feedback loops and maybe even locate those high coherence scaling nodes. Second, and more ambitious, hyperfractal time modulators. These would be active devices designed to influence temporal dynamics. The idea would be to generate very specific frequencies to resonate with desired T5 modes and see if you can locally enhance T4 coherence in a target system like a qubit. Mathematically, they'd be trying to tweak the local potential energy landscape associated with a time axis v t0 by e 10 is b50 by e3, essentially trying to tune the local time geometry for better stability.
And you mentioned those scaling moduli. The M0 up E10, XB50 by 800 by A10, XB50 by A30 by E20 by A20 XBD govern local time effects. Let's talk about temporal dilation and contraction in this model. How is it different from Einstein's time dilation?
Right, relativistic time dilation depends on speed or gravity affecting T1. In this model, dilation and contraction are more about your position or alignment within the hyperfractal. Temporal dilation time slowing down locally would happen if a system or observer is strongly coupled to deep fractal nodes that inherently has slower temporal scaling factors. These are nodes that prioritize T4 coherence, long stability over rapid T1 progression. The exact amount of slowing depends on those specific M0 by E10, FZB50 by 800 A10, FZB50 by E3, by E20 by E20 XBD values linking T1 to T4, T5, etc. at that location. And temporal contraction time speeding up locally could happen if his system is interacting with more chaotic or rapidly oscillating nodes, ones maybe not well synchronized. These nodes would impart a faster T1 progression without the stabilizing influence of T4. So localized variations in the rate of time become potential probes of this underlying fractal structure.
This is really pushing boundaries. Which brings us inevitably to the philosophical side and the ethics. If manipulating T4 coherence or T3 quantum probability ever became possible, what are the big questions and risks?
The philosophical implications are huge, yeah. Does the apparent drive towards coherence and complexity via T4 and T5 suggest the universe has some kind of inherent purpose or direction? Is it teleological? Or is that purposefulness just an inevitable mathematical consequence of a fractal geometry of time? It forces you to question if inherent structure implies intent. And ethically, that's a minefield. If T3 governs quantum chance and T4 governs stability, messing with them, even locally, could have completely unforeseen consequences. Could stabilizing one system destabilize another? Could altering quantum probabilities disrupt the causal structure of T1 further up the chain? If these technologies were ever developed, we'd urgently need a new branch of ethics. Temporal ethics, maybe, focused entirely on the responsible handling of fundamental temporal parameters. The potential for unintended consequences seems enormous. #DAGUTRO.
Wow, okay, this deep dive has really taken us somewhere else. We started with time as a line and ended up with this dynamic, multi-vector force working through a hidden fractal structure, the hyperfractal lattice. It connects the quantum world of T3 and T4 to the cosmic rhythms of T2 and T5 with our everyday time T1 just being the end result we see. And for you listening, I think the core takeaway is that dynamic dance between T4 coherence and T5 resonance. That feedback loop isn't just some abstract concept, it's proposed as the fundamental reason why stability exists, why complexity can emerge and persist against the constant pull of entropy we see in T1. It's like a hidden engine constantly working in the depths of time.
This raises an important question. The sources consistently frame our experience. T1 is this heavily processed output, a dimensional reduction from these richer, higher dimensions of time, a projection onto our reality. So if T1 is just a projection, what vital information about the true nature of reality, about past, present, future possibilities perhaps, remains locked away, encoded in the full dynamics of T2, P3, T4, and T5? What are we not seeing because we're only perceiving the T1 surface? Maybe consider this. Your own sense of time flowing smoothly, one event after another, that very feeling might be the incredibly complex, finely tuned result of this unseen fractal emergence. Something to think about. Until the next deep dive.